All right, so this video kind of branches into the idea of using proportions and ratios, but now we're actually using actual geometric shapes. Triangles will be the primary, but it could be for any quadrilateral or any polygon, really, any sided shape. We can prove they're similar, but in all these different shapes that we're going to talk about in this video, all these will be similar, okay? And that little kind of squiggly sign, again a tilde if you're in Spanish, okay? So that is a similar symbol, meaning they're not necessarily the exact same, but they are similar, okay? If they were the exact same, we would write an equal sign below it, meaning they're congruent, okay? Congruent, you put an equal sign, then the little tilde on top, okay? And again, another thing that we can do is that we put another squiggly below it, meaning approximately, okay? So usually we do that with decimals. So if we have, again, rather than writing out all the decimals of a particular number, we round and say it's approximately this, okay? So just one squiggly is called similar, okay? Now, so this statement says triangle ABC is similar to the triangle DFE, meaning they're not the same size, but they'll have a ratio between them, between all the sides, okay? So when something is similar, that means all the sides will have a ratio, meaning that one side will be equal to another side, okay? But the order is really important, okay? So the order is really important. So remember, so it's A, B, okay, so we're going this way, okay? So AB to BC, okay? And then we go back around to CA, correct? Okay? So again, I'll highlight it here with under the letter. So AB is blue, okay? BC is green, but CA, again, we go from here to here, okay? So it kind of like goes in a circle almost. So A, B, B, C, C, A. Now, you're like, why are you concerned about this, okay? Because it's similar and it has to go in the same order as the other one says DFE, okay? So what this means is that DF would mean going this direction, okay? So D to F is the same as A to B. Notice how they're both blue because those are the similar sides. Those are the two similar sides, okay? Then from F to E, okay, so from F to E, that side is similar to BC, okay? So BC is similar to FE, okay? And then lastly, ED is the same as CA, okay? So the order of which when you write similar statements for triangles, the order is really important, okay? So there's statements we can write about this. Now that we know all that, okay, so we can say if they're similar, okay, then that means there's a proportion between AC, okay, a proportion between AC and DE, right? There's a proportion, or we can make a ratio with AC over DE because of the same side. I could do the same thing with AB and DF, right, or FD, okay, because both those sides are similar. Again, those are the ones highlighted in blue. Okay, and then I also have BC and FE, right, because both of those sides will be similar. They're both sides highlighted in green. Okay, now, it's kind of confusing because look at the picture, right? One triangle is facing one way, the one triangle is facing the other way. So if I were to redraw this triangle up here, okay, if I were to redraw this down below, it would look something like this, right? So all I did was kind of rotate it a little bit. So here's A, but C is over here, and B is over here. Okay? So if I were to redraw the colors, so AB is right here, BC is right here, and CA is right here. So see how the colors are all going the same way now? And you could totally do that on your homework or on your worksheet. You can kind of redraw the second shape so that you can clearly see, oh, they are similar, right? They look the same. They have the kind of same directions and angles, but their sides are a little bit bigger or smaller, okay? So, and speaking of things that look the same. Yes, the angles look the same. Okay, so take a look at angle A. Okay, I'll use this one down here. Angle A and angle D. Okay, so see how they're in between. Angle A is between the orange and the blue line. Angle D is between the orange and the blue line. So that means angle A is equal or congruent to angle D. Now wait, I thought we were talking about similarity. We are, but the cool thing about angles, it doesn't matter how big or small the triangle is or whatever shape it is. If it's a similar shape, the angles will actually be congruent. The side lengths have a ratio or proportion, but the angles are congruent to each other. So A is congruent to D. Okay, so B down here, I'll put double arches. Okay, it's congruent to F, so angle B is congruent to angle F. Okay, and then that means angle C is congruent to angle E. So angle C is congruent to angle E. Okay, and again, I saw that in a picture, but notice the original statement they gave me up here. Okay, so see how A is first, then D. So angle A is congruent to angle D. B is second, F is second, so B is congruent to F. And C is congruent to E because E is last and C is last. Okay, so all the side lengths are proportional to their matching side, and all the angles are proportionate, or excuse me, they're congruent to their equal side. Okay, so that's kind of, if you need to watch part of that again to kind of get all that, take some notes, I would encourage you to do that, because now I'm going to show you another set of polygons, and we're going to do the same exact thing, but I'm going to go a lot faster. Okay, so all right, so it says WXYZ is similar to MNOP. Okay, so again, so I'm going to do WX and MN. Okay, so WX is here on top, and MN is right here. Okay, so that's in red. I'll do XY and NO in orange. So XY and NO. Okay, so those are the same. Okay, and then I'll do YZ and OP. So YZ, OP. Okay, and then of course we go around the horn, as we say, it's the ZW and PM. So ZW, PM. Okay, so again, I have colors. If you have highlighters, I would recommend pulling out those. Those are super helpful. Okay, so these are similar shapes. Okay, now if I wanted to, okay, I can rewrite the top one. Okay, I'm going to rewrite this one down below to make sure all my sides are kind of matching. So they're facing the same direction, but I have to make sure I put the letters in the right place. Okay, so if I did it again, it would look something like this. Okay, so X would be here, W would be here, Z is back here, and Y is right there. Okay, so again, if you just wanted to kind of flip it around, that's what it would look like. Okay, so I can write these statements because of that. Okay, so I could write, I know that the red line, so WX, is proportional to the other red line, MN. Okay, I know the blue line, excuse me, the orange line, XY, is proportional to NO. I know that the green line, YZ, is proportional to OP. And then around the horn, ZW is proportional to PM. Okay? So all those side lengths are proportional to each other. All right? And then for the angles, again, just match up the angles properly. Okay? So it starts with angle W is similar to angle M. So angle W is not similar, but congruent, excuse me. Congruent to the letter M. Okay, and then we have angle X is congruent to angle N. So angle X is congruent to angle N. Angle Y is congruent to angle O. And angle Z is congruent to angle P. Okay, so those are all my similarity proportional statements as well as congruent statements. Okay, so that kind of gives you an idea what we're doing. The order is super, super, super important. Okay, and the next slide here, we're going to use that knowledge. Okay, and we have to find out if these sides are proportional to each other. Now, it makes it super helpful if they're all facing the same direction. Okay, so we're going to find out, are these shapes similar? So, given that we have the numbers, are triangle ABC and triangle DEF similar? Okay, so again, this side DE matches this side AB. Okay, so I'm going to write 6 over 5. Okay, and if it is similar, then that means this side here, BC, should be similar to this side here, 3, 4. So 4 over 3. Okay, so now we're checking if we cross multiply, do we get the same answer? Okay, 6 times 3 is 18, and 5 times 4 is 20. So does 18 equal 20? No, it does not. Okay, but I know what you're saying. Well, wait a second. Well, what if we did this side here, AC and DF, right? So if I had 6 big over small, so 6 over 5, and then equals 6 over 5, that's true. But the proportions have to work for all the sides. It has to be proportional to every side. It can't just work for a couple and not for others. Okay? So these triangles are not similar. Not similar. Okay? But let's take a look at the rectangles here. Okay? So for the rectangles, this side, WX, is 24. Okay? And the small rectangle, DA, is 6. Okay? And let's see if this side here, WZ, 16, is the same as this side here, DC. Okay? We can cross multiply to figure it out, but let's go ahead and take a look at the fractions. 24 over 6, doesn't that equal 4? Right? And 16 divided by 4, doesn't that equal 4? 4 equals 4, right? Cha-ching, these are similar sides. Okay? And now I don't need to check the rest because, look, CB is the same as DA, and AB is the same as, okay? So I don't need to check all those sides. I just need to, like, you see that they're all the same, and you check. So if I did all this, if I did all the ratios, you would see that it would be the same. 4 equals 4 equals 4 equals 4. Or the ratio, if you reduced it, would be 4 over 1, 4 over 1, 4 over 1. So number 5, both of those are similar shapes. So the statement we need to write is, okay, starting with WXYZ is similar to, and we go in the same order, so we start in the top left. So here we start at the top left, DABC. So WXYZ is similar to DABC. Okay, so wherever you start, make sure you start in the same place. Excellent. All right, so that's what you need to know, and you'll have a worksheet, and we'll talk more about this in class tomorrow.